The purpose of this clip is to show and demonstrate examples of aggregation framework in MongoDB Shell and Mongo Compass. The first part of this video, I will show the aggregation framework in MongoDB Shell. First, I will show the viewers. This is the collection that I'm dealing with. It's called lease agreements. And you can see here we have property address, capacity, number of residents, year built, market value, desired lease, property type, deposit payable and monthly rent. We have two arrays, target market, payment methods, and we've two embedded documents called letting agent and landlord. So the first question I will use here is we want to separate out three buckets and allow Mongo to group these based on the market value and show the max market value in each bucket and the average market value per bucket and the number in each bucket. So you can see here we've just chosen to pick number 3. So the $ bucket auto allows us, the users, to give MongoDB the opportunity to group them by themselves. If we wanted to group by ourselves, we could just do the $ bucket. But with this way, it ensures that it's kind of evenly spread as such. So you can see here the max market value per bucket is calculated by the max, the $max, and then in double quotes, $market value. The average market value per bucket is found by $average, and then double quotes, $market value, and the number of properties per bucket is found by the sum, $sum, it's :2 or :1. So if we run this, I will just show you what it looks like. So you can see here it's grouped the dropped the three categories of market value. The first one is between 100,000 to 225,000. The second one is 225,000 to just under, not including 400,000, and the last one is from 400,000 up to and not including 750,000. So you can see here the max is 175 for the first part. Then the next one, the second bucket, is 350,000, and the one after that is 700,550. The average market value per bucket is just under 13 or 100,035 K. So so basically the second bucket is 274,000, just under 275,000, and the final bucket is just under 700,000, €696 K, sorry. And then in each bucket can be seen here how many are in. So you can see here that there's kind of a slight from 400,000 down. There seems to be the majority of our say houses. There's only 125 that have more than 400,000 K worth of market value. So like you can see that there, that it's very separated out. So if we want to say separate out even more, sorry, as I previously showed, that it was kind of or drift more towards the cheaper houses, we want to separate out more into more categories so we can gain more of an insight. So in this case, we're going to use the bucket number. I'm going to put it to 4. So we're going to tell MongoDB to separate out into 4 distinct categories or buckets, so we say. And again, we're using the $ bucket auto in order to do this. The project, this means that it will show the market value for us and not show up the ID. So ID is equal to 0. So we're going to run this. So you can see here now that there's 4 distinct groups. The first one is 100,000 to 150,000. The second one's 150,000 to 250,000. 250,000 to 400,000 is the third one, and 400,000 to 750,000. Now you can see here that there's kind of the average is slightly changed, but not really much. Kind of like also you could with the extra bucket, there would be slight variations anyways. But you can see here at the end the number of properties per bucket is generally more spread. The only say bucket that didn't really change as you can see from here to here and here to here is the last bucket from 400,000 to 750,000. It's the exact same for the bucket. So MongoDB decided to switch up the bigger groups of properties into smaller buckets. So you can see here there's 264 properties between 100,000 up to and not including 150,000. 150,000 to 250,000. There is 294, and from a quarter of a million up to 400k is 317 properties. So let's say there's an argument within a workplace or in an auctioneer's place that houses that were built after 1995 are more expensive, and the ones say belowhand or that were made previously to 95 cost more. This would be a suitable way to say find out. So we can split it up into 4 buckets and only include properties that are built after 1995. So you can see here this part of the code is generally the same as mentioned previously. The only part we've included is the match. It's a match function. You can see here that we put it in curly brackets year built, which is the column or the column name, and we've used this function, the star GT. So that means anything greater or anything past 1995, so 1995, so from 1996 onwards. So we're going to run this just to see and compare previous output to this. So you can see here roughly the buckets are the same, they haven't changed, and either have the max market value. However, the average market value per bucket has slightly changed. So you can see here that there's a slight increase in, say, the average market value per bucket in the 100,000 to 150,000. So this is a slight increase, but it's not really much. But this could suggest that maybe maybe the more expensive houses that were built after 95. In the second bucket, 150,000 to a quarter of a million. This really hasn't changed much, so that kind of doesn't really help our answer. In the third bucket, it's roughly the same as well, 200,000 and 94. And then the last one is roughly the same as well, give or take 10,000 or that. But generally, to answer that question, it'd be very hard not to say that houses beforehand cost less or cost more, because depending on the nature, there'd be other factors that would need to be involved, such as space and other facilities involved in the house. So now I will take you on to Mongo Compass. So you can see here we want to show the amount of evictions that can be calculated. So we're just given the fact that you use this to subtract the number of residents from the capacity of the property. So when you're looking at houses that are built in 2005 and it has 4 methods of payment in that array. So we want to display the address, the year build, property type, a number of evictions, and sort from eviction from highest to lowest. So you can see here, it's quite useful. You can see here all the documents in the collection. And the first part is, you can check here to enter whichever function you want to use, which is the match. So we're looking for the years built in 2005, payment methods, size 4. So it's only we want this to show the value 4. You can see here, pay method, it shows us 4 arrays or 4 values within that array. So if it had only 3, it would not be involved here. And likewise, if it showed 5 or 2 or 1 or none. So you can see here right across, there's 20 that have satisfied this condition. So the next part is we're looking to show or project, that's the function here. We want to show the property address, the year build, property type, and we're given Mongo Compass the function that we want to find. Say like number of evictions is found by subtracting the number of residents to number of capacities, or the capacity of the house. So you can see here we still have 20. However, you can see here that we have the number of evictions is 0. And the next one, which doesn't really make sense, is the number of evictions is -2 in Dundalk. So in order to, obviously you can't have -2 evictions within a house. So in this way, we just for this case, we wanted to show all the all the houses that have been evicted or have evicted or in the past. So to use this, we have set the number of evictions to greater than 0. So you can see here now we eviction 2, 1, and 4, and we only have 12 documents within this compared to the 20 from beforehand. Now we want to sort it from highest to lowest, the number of evictions minus 1. And if we want to say from lowest to highest, it'll be 1. So you can see here the highest amount based on the data or input we've given it is 4 evictions in Dundalk. Now I just want to roll back to Mongo Shell for one quick thing. We want to show you for each payment method, within each payment method by property, we want to list the methods, the property type, and the highest monthly rent for each payment method and property type combination. So we want to only show the highest monthly rent that exceeds 900 a month. We want to sort by the highest monthly rent in ascending order. So you can see here we've the unwind function that we've never seen. Basically, this destructs an array and it gives it each value a part. So for example, ID 1 will have 4 or 5 or 3 depending on what was in the array. If there's 3 payment methods, it'll have 3. And just for this sake, even though it's not an array property type, I've included that just for the sake. So we want to group by payment methods, property type, and we want to find the maximum rent as well. And we want to ensure that the math symbol, we want to make sure that the max rent is greater than 900 euros. And finally, we want to sort in ascending order. So this is 1. So I'm going to query this in the shell. And you can see here, it's looking for it. However, this now is showing all the specific payment methods that was in our array after we unwinded it, and the property type that you can find, and the max rent You can see the max rent is 1,000 anyways. However, this is quite useful for, say, anyone that could only pay by, say, a check, or could only pay by cash, or vice, or whatever, and you wanted to live in a specific house, that you can see how much is rent that you can, say, pay, the maximum rent that you can pay. This is why MongoDB is quite useful. Thank you.